Alright, ladies and gentlemen, so in this video we have a goal to evaluate definite integrals by substitution. So far we've really just kind of focused on indefinite integrals, not having any upper or lower limits attached to those integrals. So now we're going to look into actually integrating a definite integral via substitution. So let's take a look at the example that we have on the board. We've got tangent of x times secant squared of x of the integral from 0 to pi thirds. So now we're talking restrictions. We're really focusing on what is the area under this curve from 0 to pi thirds specifically. Well, let's kind of not necessarily worry so much about the 0 to pi third to start off with, and let's just kind of focus on the integrand itself and how we can integrate this. So remember, we want to choose a u for u substitution that when you take the derivative and get your du times blank dx, you will have it left in somehow, some way. You will have that derivative inside of your integrand still, so that you have the capability to actually substitute and to swap it out. So let's think about what we can do here. Well, let's take a look at secant for a second. If you take secant, then you're left with secant tangent, and then it kind of could be a possibility to use, but you might have to do a little extra work into doing that. But let's look at the possibility of making tangent our u, because think of what we know about tangent. The derivative of tangent is secant squared. So your life is pretty easy when you can just go ahead and choose one, and your derivative is exactly what is left over inside of that integrand. So if we go ahead and make u tangent of x, that means du is secant squared x dx. Well, looky here, folks. We've got the exact same thing on both, right? So there's our secant squared and our secant squared, and there it kind of matches on up. So now when we get to this point, this is what allows us to go ahead and to be in substitution mode. Tangent was u, secant squared dx is du. And so now we just need to integrate. So now we are integrating, so we will raise the power of u, so that'll be 2, and divide by that new power. So we'll get u squared over 2, and we're evaluating that from 0 to pi thirds. Upper limit pi thirds, lower limit being at 0. Okay? So let's kind of continue to push forward a little bit here as we kind of see, I don't know, what the difference is between each of them specifically. But we gotta look in for a sec, alright, as what u really is, right? U really is tangent x. So you have a couple different ways you could go about this. You could substitute 0 and pi thirds into tangent x and get that value, and you would end up with 0 and the root 3. And you could substitute that on into u, or you can go ahead and substitute tangent back into u, and then you could go ahead and evaluate from 0 to pi thirds. Okay, so once again, two options. Option 1, throw 0 and pi thirds into u, which is tangent x, and you would end up being that the tangent of 0 is 0 and the tangent of pi thirds is the square root of 3. And so you could get those two specifics from there. Okay, and option number 2 is you could take u, which is tangent, and substitute tangent back into u and do it that way. It really doesn't make a difference of how you want to go about it. I know a lot of scholars like to throw these values into u. So let's just go ahead and let's take care of that first and foremost. So I'm going to go ahead and put this over here just like this and say that tangent of pi thirds is equal to the root of 3, and then tangent of 0, well, that is 0. So what this really ends up showing us is that we're not going to be evaluating u from 0 to pi thirds. We could maybe evaluate tangent, but not u. And so u squared is actually from 0 to square root 3, because u actually is tangent itself. And so this one ends up giving us, well, square root of 3 squared over 2 minus, if it was before, 0 squared over 2. Well, this just ends up simplifying on out to 3 over 2 in the end. Alright, so that's kind of how we can go about what happens when we have our u substitution being involved inside of our definite integrals there. So I've got one to give a shot on your own. Let's take a look here. The problem that we are going to be diving into, if I can find it on the page, is going to be here. Pretty simple, pretty similar to what we were just doing here with this specific one. Actually, let's switch it up a little bit. Let's do a non-trig function one. Let's take the example of -1 to 1, 5r over 4 plus r squared, and that is all quantity squared dr. And once again, we want to evaluate that integral from -1 to 1. When this is all said and done, hopefully you end up with a final answer of 0. Alright, folks, good luck, and on to the next one.